Hello everyone, in today's video we will be doing your worksheets from throughout the week. So we will be beginning with this worksheet right here, which asks us to basically just put the points that should be at these coordinates. So let's begin immediately. 1, 3 is at 1 step to the right, 3 steps up. Here, I'll make this a little bigger so that you can see exactly where it should be. 1, 5 is at 1 to the right, 5 up, so here. Then 3, 7 is at 3 and 7 up, so there. 5, 7 is at 5 and then 7 up, so there. 7, 5 is at 7 to the right and 5 up, so right there. Then 7, 3 is 7 to the right and 3 up. There we go. 5, 1 is at 5 to the right, 1 up. 3, 1 is 3 to the right, 1 up. All right, there. 1, 3 is, again, the same point right here. And it asks us to, if we unite them, we can see a hidden shape. So in that order, in the order that we made them, actually. And this shape is an octagon because it has 8 angles, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes, an octagon. Okay, so this asks us to move the shape in the following way. Let's first make a shape that is an exact copy of this. All right, now it wants us to move 2 spaces to the left and 4 spaces down. So 1, 2 spaces to the left, and then 4 spaces down. 1, 2, 3, 4. I actually moved a little too left. There we go. Okay. And now we need to write the coordinates of the corners of this shape. Okay, so I'm going to start from here and then move like this. All right, so the first corner at the bottom is at 1, 2. And the second one is at 1, 3. And the third one is at 5, 3. And the last one is at 5, 2. And there we go. Those are the coordinates of the rectangle that was formed. So if you need to check your answers, pause the video right now. This is the back page, and this asks us to create the shape again, but on this side. So we need to imagine that this is a line of symmetry that has cut this image in half. So we need to make it so that we need to place a rectangle on this side so that they are symmetrical. So they need to mirror each other, okay? Okay, so let's do that. There's no one specific way to go about this. all you need to do is try to think, okay, if there were a mirror here, what would it show on this side? So basically, we need to think, okay, well, since this corner is one dot away from, one space away from this line of symmetry, then it's going, this corner correlates to this corner right here. Then this one is 1, 2, 2.5, so it's going to be uh, half, 1, 2 right here. And this one, this is a little trickier. Here we need to go 1, 2, 3, 3.5. So then that would be, wait, sorry, I lost it. 1, 2, 3.5. Half, 1, 2, 3. So right here. And you can see that in order to make this a rectangle again, the other one would have to go here. The other way you could have gone about this was if you figure out the coordinates. So here, if you figure out the coordinates of each point, so here the coordinates of this corner are at 7, 9. Then if you, let me write that. 7, 9. And if you flip those around and you do that for all the corners, then you're going to get the symmetrical shape. So let's see. 7, 9. So the opposite of that would be 9, 7. Well, 9, 7 is at 9, 7 right there. 9, 7 right there. Then the coordinates for this corner are at 7, 12. So we're going to go to 12, 7. 12, 7 right there. Then this one up here has the coordinates 2, 12. So we're going to go to 12, 2 right here. Next one has coordinates, this one has coordinates 2, 9. So we're going to go to 9, 2. And there you go. There's your symmetrical rectangle. Symmetrical to this one. Okay, now this is different because the line of symmetry is not like this anymore. Then now we have to do what we did in the first case before. So we need to measure the distance of each point from the line of symmetry and then make that same distance in the other direction. So here we have 2 points that are 2 steps away from the line of symmetry. So we got to put them 2 steps away on this side. And then we have 1 point up here that is how many spaces away? 1, 2, 3, 4, 5, 6. So we're going to go 1, 2, 3, 4, 5, 6. And that's our shape, our symmetrical shape. There you go. So if you need to check your answers, make sure you got them correct. You can pause the video now. All right. Yeah, we can go here. All right, so again, here we have to deal with coordinates. And here we need to find out where the truck is going to be after going 3 blocks east. So this way is east. And then 2 squares north, which means up. So 1 2, 3 blocks east, and then 1, 2 blocks north, which means they'll be here. They'll be at B. So B. Here we are playing a game, and you can see here, down here, we have letters now instead of numbers. So we are being asked what movements does this piece need to make to get from here to this spot right here. So that would be that it needs to move 1, 2, 3 spaces right, 1, 2 spaces up. So 3 spaces right, 2 spaces up. Why did I write 2 twice? There we go. So check your answers for that. And let's move on. Actually, no, let me close that. All right. Oh, so we had to choose from these. So our choices here could have been, no, this one is wrong. This one has it backwards. This one is going the other way. This one is correct. And this one's going the other way. So here we have a board game, right? And it's asking what piece is at the position 2 delta, and that would be the airplane. So here's my answer. Again, check your answers, and let's move on. And again, if you need to take a moment, just pause the video if you want to check your answers. All right, now let's find the exercise. Okay, so this one was about the scale, but this first part is just theory. So let's go straight for this one. Okay. So here we're being asked to what scale we have made this room. So this is imagine that this is the map, whereas these are the real dimensions. So what it's saying is that 4 centimeters on the map are 4 meters in reality. So we could say 4 centimeters on the map are 4 meters in reality, but there is a better way to write this. We could say that, not equals, we could say that 4 centimeters is 4 centimeters on the map is 400 meters in reality, 400 centimeters in reality, because 4 meters is 400 centimeters. But there's an even better way to write this. Instead of talking about 4 to 4, I could just say, well, if 4 centimeters is equal to 400 centimeters, then that means that 1 centimeter is 100 centimeters. And I could also just remove the centimeters completely. So I would say that the scale is 1 to 100. Next up, we have a map. And on this map, we see a distance that on the map is 2 centimeters. And we see that the scale that the map is made to is 1 to 800,000. That means that 1 centimeter on the map is equivalent to 800,000 centimeters in reality. Now, 800,000 centimeters. Let's think about this. 1 kilometer is equal to, let's think about this, 1,000 meters. So that would be 100,000 centimeters. Yes. So if that is true, then on this map, we would say that 1 centimeter, since it correlates to 800,000 centimeters, that means it's the same as 8 kilometers, right? So 1 centimeter on the map is 8 kilometers in real life. Now, since the distance is 2 centimeters on the map, that means that the real distance is 2 times 8 kilometers, so that would be 16 kilometers. Do you understand? Because 1 centimeter is 8 kilometers, 2 centimeters will be 2 times this, so 16 kilometers. Okay, next up. So we have that the real distance between two cities is 50 kilometers. And then we're being told the scale to which the map is made. So 1 to 1,000,000. So that suggests that 1 centimeter on this map is equivalent to 1,000,000 centimeters in real life. We'll talk about that in a minute. And it's being the question is, what will be the distance on the map if we measure it with a ruler? So let's figure this out. Here it's saying that 1 centimeter on the map is 1,000,000 centimeters in real life. Well, let's figure out first what 1,000,000 centimeters is in kilometers. In kilometers, 1,000,000 centimeters is 10 kilometers. All right, so 1 centimeter on the map is 10 kilometers, right? But the real distance is 50 kilometers between the cities. So we need to figure out how many centimeters is it going to have to be so that when I multiply it by the distance that is equivalent to each centimeter in real life, so 10, I'm going to get 50 kilometers because that's the real distance. So basically the question is how many times 10 makes 50, which of course is 5. So my answer should be that the distance on the map will be 5 centimeters. And there we go. That's exercise 3. Next up, we have here a geometry review. So this is theory again, which you should go through, can be helpful. But all of these are things that we have talked about many times over the past years. So this first question asks, what are the pairs of parallel and then intersecting lines? So the parallel lines here, the pairs will be A and B, and then the second pair will be gamma και delta. Let's just write it in Greek. Alpha και delta, gamma και delta. And then we want the pairs of intersecting lines. So A intersects with C, so gamma. A also intersects with delta. Then vita intersects with gamma. And vita also intersects with delta. So this is the first exercise. Then it wants us to make 4 lines. Alpha and vita need to be parallel. gamma and delta. No, gamma needs to be perpendicular to both A and B and beta, and delta just needs to be intersecting all three. So let's first make the two parallel ones. We'll call these two alpha and beta. All right. Then gamma needs to be perpendicular to the two, like so. So this is gamma. And then delta just needs to intersect with all three. So that can be, well, even if you make it like this, where it doesn't necessarily intersect with gamma right away. If we were to project these two, they would at some point intersect. But if you want, you can make it so that, yeah, it is intersecting with all three, here, here, and here. And this is delta. So there we go. Next up, we want to, this is a review from last week. We want to create the heights of all three triangles. So let's do that immediately. We are going to make perpendicular lines. So here, then from here, we're going to make a perpendicular line here, and then one from here to here. This is a right triangle, so these two are already heights, right? And then another one goes right here. Then we have this last one. And it's almost like an isosceles triangle. There we go. And next we need to make perpendicular lines at the halfway points between these two lines. So I should measure the distance between these two, find that the halfway point is somewhere here, and then bring perpendicular lines like this. So here, for example, I have not made it correct. I have made it too far to the left. I've made it, it needs to be somewhere here. All right, next up, this one should be somewhere here. This one should be here. Nope, nope, definitely not. Closer to here, yeah. Then we have this. Be careful, they need to be perpendicular, so if I just bring something like this, that's not perpendicular. So you're going to need to use your ruler on this one. This is what they should look like. And here we need to categorize the lines into intersecting and parallel. So here, I'm going to write in Greek the nominus, because they do intersect. These two will intersect. They're most certainly not parallel, even though they do not intersect on our paper. If we were to project them a little bit, you see basically that one comes closer to the other. If one comes closer to the other, then they're not parallel. These ones look parallel. So we're gonna say that these are parallel. And these ones are intersecting on not on screen, on paper. All right. That's this exercise. So pause the video if you have to. Next up, our last two exercises, the reviews. So here we basically need to put a tick whenever um, a triangle falls into a specific category. So we have the categories based on sides, and here we have the categories based on angles. So let's get started. Is this equilateral? No, because this side is longer. Is it isosceles? Yes, it seems so. These two sides seem to be equal, so if it's isosceles, it's neither of the other two. So you're just going to pick one from each of the two categories. Let's think about it this way. These are the, come on. These are the two categories, and each triangle cannot belong to more than one on each side. Okay, so here it's isosceles. Here does not seem to be a right angle. This does not seem to be a right angle. These two are obviously acute. This one seems to be obtuse. So obtuse. Next one. This is none of these sides are equal, so we're going to say scalene. And it also does not seem to have a right angle. This angle seems to also be obtuse. So there we go, obtuse triangle. This one seems to have all three sides equal. Okay, so I wasn't sure. So let's just bring in the ruler and measure this. Okay, this seems to be 5. No, see, this side is 4. And then let's measure this side as well. So it's definitely not equilateral, but it could still be isosceles. Okay, so we're going to call this side 4 as well. So 4, 4, 5. So that would be isosceles. And it seems like all three angles are acute. So one tick down for acute. Here we have a right triangle right there. There's a right angle. So first tick for the right triangles. And none of the sides are equal, so scalene again. And this is an obtuse triangle. You can see the obtuse angle right here. Many obtuse ones. And also no sides are equal, so scalene. There we go. So that's this exercise. I hope it didn't give you any trouble. Let's move on. Okay, so in the last exercise, what we need to do is we need to talk about each of these angles. So it's a little review on angles. The first question asks, how many degrees is a right angle? And that would be 90. Then we have how many degrees is an acute angle? And that would be less than 90. Then how many degrees is an obtuse angle? And that would be more than 90. Lastly, we have the question, how many degrees is a straight angle? And the answer would be 180. So then we need to name each of these. So this right here is the right angle. And I can write it for you in Greek. And this is obtuse. And this is acute. The last one is the straight one. So, all right. And now this one asks us, how many degrees each of these angles is. So let's try and figure that out. So here you can see that the line crosses 110 and 70. So you might be wondering, okay, well, which one is it, 110 or 70? Well, first of all, if you look at the angle, you immediately see that it is acute, meaning that it needs to be less than 90. But also, you could say, okay, since this side is the one touching the protractor, I'm going to start from the zero that is here instead of here. So that means I need to follow the inside set of numbers, right? Not the outside, the inside, which means that this would be 70. Here it crosses 40 and 140. So again, you can look at the angle and you can say, since it's obtuse, it needs to be more than 90. So that would make it immediately 140. But if you didn't want to go that route, you could also say, okay, since again this side is touching the protractor, I'm going to follow the zero that starts on this side, meaning the inside set of numbers again. So this is the correct measurement, 140. And that is your last exercise. So that will be all for today and this week in general. Have a good weekend. Do your homework. And see you again on Monday. Bye.